Okay, so let's do the 9th question, paper 1, question number 9. So here what we have a pole or a rod inside a liquid. There are two liquids. So just like this, in between there are liquid 1. Let's say this is having a density of 6 rho and this is having a density of 2 rho and the rod is having a density of rho. So we have something like this. What we are going to do is we are going to tilt it a little, something like this. We will be tilting it at an angle theta. So what happened means here there will be a buoyant force, right? There will be a buoyant force as well as mg is also acting downward. So what I am going to do is I am only considering this portion. I am only considering this portion from here to here. So at this point, at the midpoint, mg will be acting in downward direction. In this direction you will be getting mg. So instead of mg, what I can write is mg, instead of mg I can write mg will be equals the weight of the rod from where to where, from here to here. That will be rho into, that is the density of the rod, and half of the volume of the rod into g. Like this I can write. So here I will get mg now downward direction, or m, instead of this mg what I can write? I can write rho into v by 2 into g in downward direction. In upward direction what will be the force? The force will be, in upward direction, the force will be, what about the buoyant force, right? Buoyant force will be, I can write buoyant force will be rho into 6 times rho into half of the volume, this is the volume displaced, and g, this will be the buoyant force. So I will call this point A, and at the center of this portion is B. So net force, this is buoyant force, net force at A will be equal to what? 6 rho v by 2 into g minus rho v by 2 into g. That will be 5 times rho v by 2 g. Similarly, you will get another, similarly the same method you will be getting, and net force at B something like rho into v into g by 2. Why this? Because here we have rho v, rho 2 times rho is the density, right? So that will be the net force here. So but this force will be exactly upward direction. What we are going to do is we will be resolving the force perpendicular and along the direction of the rod. So there will be a theta, and the component of the force, perpendicular component will be, the perpendicular component will be 5 rho v into g by 2 sine theta. And this is the perpendicular component at A, and the perpendicular component at B will be what? Saying rho vg by 2 into sine theta. So now we are going to discuss about the restoring torque. Restoring torque. Torque will be equal to what? Force into displacement, right? So up to the point here, the displacement will be L by 4. So you will be getting 5 rho Vg by 2 sine theta into L by 2 plus one more torque is there, that will be rho Vg by 2 sine theta into up to this point B, that will be 3L by 4. So if you are observing the, here it will be not 2, it will be 4. So you will be getting the denominators are 8. So what you can do? You can add it directly. So you will be getting tau will be equals 5 plus 3, that will be 8 rho Vg by 8 into sine theta into L. So 8 will cancel, and for the small angle approximation you will be getting what? This angle which we are tilting. This angle is very small, so you will get rho Vg L into theta. This will be the restoring torque. Because of the restoring torque there will be a negative sign. So we know that I alpha equals minus rho VGL theta. So take it the other side. So I alpha plus rho VGL theta. So now this is the type of standard equation. This is the standard equation, right? So I need to divide it with I in order to get the omega. The standard equation is something like this. Omega square theta equal to 0. So we are comparing it with this equation. So I value will be what? I will be ml square by 3 m is nothing but rho v L square by 3. So we'll get omega square will be something rho v g L divided by rho v L square by 3. So omega square will be what? Rho will cancel, Vv, and G will be there. There will be this one will also cancel. You will be getting 3 times G by L. This will be the omega square. So we got the omega square. Then what we can do right now? We got that value. So we got omega. Then omega will be root over 3G by L. So time period we can get 2 pi root over L by 3G. So n will be what? Root 3. So we can say D is equal to 1.73. So the answer is 1.73. That's it. Thank you.
Okay. So let's have a look at the 10th question. This is based on a cascading Carnot engine. This was asked previously in JEE mains as well. It says, shown in the figure are 5 Carnot engines with efficiency eta, same number of cycles per unit time, operating between 6 heat reservoirs. The amount of heat, the heat released by the first one is absorbed by the second one, and so on. If the heat absorbed by the first engine is Q0 and the total amount of work done is W, then the net efficiency of the system, net efficiency is total work output by heat input, is given as 211 by 243. And you have to find what is the efficiency of each Carnot engine. So this is first reservoir, some Q0 amount of heat is absorbed here, and the work output is in W1. Some Q1 amount of heat is rejected here to the second reservoir, and that becomes the input for the next Carnot engine, where the output work is in W2, and some Q2 amount of heat is rejected, and so on all the way up to the last one, where some Q5 amount of heat is rejected. So let's just write down whatever is given. It says for each engine the efficiency is the same, eta. So that is W1 by minus Q1 by Q0, which is also the same as 1 minus Q2 by Q1, which is the output and input for the second one, so on, all the way up to the last one, 1 minus Q5 by Q4. The net efficiency is the net work output by the heat input to this entire system. This will be up to Q5. This adding up the work extracted from each stage. And for the first one, this will be Q0 minus Q1. For the second one, it is Q1 minus Q2, so on, up to the last one, where it is Q4 minus Q5. All the cross terms cancel, the first and the last term is what you have left. And this is given as 211 by 243. But to get an expression for Q5 by Q0, just notice that from the first one, you can write Q1 by Q0 is 1 minus eta, and this is also Q2 by Q1, Q3 by Q2, so on up to Q5 by Q4. So if you multiply all these terms, you get Q5 by Q0 is Q5 by Q4 into Q4 by Q3. This is 1 minus eta power 5. Right? So it's given 211 by 243 is 1 minus eta power 5. That gives you 1 minus eta power 5 as 1 minus 211 by 243. That is 32 by 243. Okay. So we need eta. The fifth root of this is 1 minus eta is 2 by 243. 2 by 3 or eta is 1 by 3. So question number 11 says there's a insulated container fitted with a thermally conducting immovable partition. So the first one, it's thermally conducting but it's fixed, P1. And the second one is thermally insulated and free to move. The partition P1's conductivity is K, cross-section area is A, and width is X. Both the partitions have 1 mole of monoatomic gas. And P2 is free to move, so it will move such that the pressure, internal pressure is equal to the external pressure, which is the atmospheric pressure. It says the initial difference in temperatures between S1 and S2 is delta T naught. The time it takes for the temperature difference to drop to delta T naught by 2 is given as some Nx R by Ka, and we are supposed to solve for N. So that's the question. This is let's say initially the temperature here was some T1 naught, T2 naught. So let's write that down, initial temperature difference, T1 naught. This is called given as delta T naught. For ease of notation, I just call that theta naught. As heat flows from here, the temperature here decreases, the temperature here increases, and this piston will slowly move outward to keep the pressure constant. So this is the isochoric process, and this is an isobaric process. So each of them contains 1 mole of ideal gas. So later, let's say the temperature here is some T1, the temperature here is some T2. I can write T1 minus T2 is some theta, which is the temperature difference at a later instant. Differentiate throughout with respect to time. You get dT1 by dt minus dT2 by dt equals T theta by dt. Also, I can write dq by dt, the rate at which heat is transferred across this. Fourier's law, heat conduction, you can write this as Ka by x times temperature difference at that instant, that is theta, which is also equal to, as this loses heat, the temperature of the compartment on the left will decrease. So I'll write minus 3 by 2 R d T1, that is NCV dt for the isochoric process, which will also be equal to plus 5 by 2 R d T2, isobaric process for S2. And from here I can replace dT2 as minus of 3 by 5 times dT1, which will give me an expression for d theta in terms of dt. dt2 is minus 3 by 5 dt1. Substitute that here, 1 plus 3 by 5, 8 by 5. Now I can. So I need to find the temperature difference as a function of time. Right? So I need an expression with d theta by dt and theta. So I'll write Ka x by theta is minus 3 by 2 r. This is called differentiate with respect to time, d theta by dt, d1 by dt. and dt1 by dt is 5 by 8 d theta by dt. So rearrange the expression to get dt is minus 15 r x by 16 k a d theta by theta. And once you see this, you must be able to recognize quickly that, so this is initially some theta naught. We want to find out how much time it takes to drop to half the initial value. 0 t is minus 15 by 16 r x by k a. ln, upper limit, lower limit, you get a ln of half, which is minus ln of 2. So this will be 15 by 16 ln 2 times r x by k a. The value of ln 2 is given in the problem as 0.7. So if you substitute that, you get this as 0.656 times r x by k a.
Question number 12, paper 1, JEE Advanced 2026. Alright. JEE Advanced 2026, paper 1, question number 12, physics. Paper 1, physics. Okay. So this is the given data for us. Right. Right circular cone, they have given height of the cone, right? Nothing but h, okay? Right. A charge is distributed, yeah, something like this. If this is the cone, right? This is the cone, charge is distributed here. Yeah, this is circle actually, right? So, charge is distributed. So, surface charge density sigma is nothing but q by a, that is q divided by, yeah, only this surface area, right? So, it has to be pi r h. H is the height given, r is the radius, okay? Surface charge density. Now, it is being rotated. Yeah, this is your point, that is origin. This is nothing but z axis, right? Somewhere here there is a point, right? Let us say that is point P. From here, it is at a distance of z. That's what they said, okay? For this, what we do is, yeah, can I have a color chalk? For this, let us consider some element, the charge element. Yeah, it can be in the shape of a element. Yes, this cone is assumed to be a combination of several elementary rings, right? That's what I am taking here. This is my elementary ring. Yes, this is. Radius of this is small r. Assume it is having a thickness, right, dy, and it is at a height y. Let me use this here, space here. This is at height y from the point O. I will consider this as angle alpha. Observe this one. Tan alpha r by h is equal to small r by y. Capital R by h is equal to small r by y. Okay, so that means y is equal to, you can say, or else you can do one thing. Y is equal to rho. Or else let us directly replace this. Small r is equal to capital R into y by h. Okay, right? Now, due to rotation, yeah, on this elementary ring, yeah, I am putting the shaded portion. Charge, can I take it as dq? dq is equal to sigma, right, multiplied by dA, right? dA is nothing but, yes, this only, area of this strip, okay? Yeah, this is 2 pi r into dy. So, this is sigma into 2 pi r into dy. In place of r, I think I can substitute that here. So, if you do that, yeah, I think we can use the space here. dq can be expressed as sigma into 2 pi into capital R into y by h whole multiplied by dy. Yes, I think up to it's clear. Now this is under rotation. Charge ring under rotation produces magnetic field here. that field I will consider this as, right, dq is equal, yeah, first current di due to rotation of this fellow, it is nothing but dq into omega by 2 pi. Basic formula. Current is produced due to circular motion of charge also, translatory motion as well as circular motion. Circular motion, this is the formula. In place of q, on the ring, distributed charge is not q, it is dq. Q is the distributed charge on the whole surface. On the whole surface. I am considering small elementary ring here. Got it clear? Yes, dq you have to substitute here. Now due to this di, yeah, as if this is current carrying circular coil, this elementary ring producing magnetic field here. So this is Z. So here guys, magnetic field dB, okay, is nothing but mu naught, yes, into Ni r square, right, into 2 by r square plus x square whole power 3 by 2, general formula. In place of n number of turns, this is not a circular coil, so n it has to be 1. Mu naught into di into r square, that is r square here, divided by 2 into, yes, maybe if you can take this as small x, 2 into r square plus x square whole power 3 by 2, that's what we consider actually. But this x is equal to, you can put right here only, z minus h, okay. So if you put x is equal to z minus h, he clearly says that z is far greater than h. So overall what happens is total, yeah, magnetic field dB, approximately you can mention this as mu naught into di whole multiplied by r square divided by 2 into, you can express this as z cube. Based on the given assumption, now total magnetic field at P, there are so many elementary rings, right? There are so many. Total magnetic field at P due to all the elements, you have to integrate it. Magnetic field at P, yes, implies magnetic field at P integral dB, that goes from 0 to capital R. Okay, so if you want, you can also make use of this expression, right? dr is equal to capital R into dy by h. You can substitute here. Yes, observe this carefully. Yes, here only. di is nothing but this one. In place of dy, right? In place of dy, you can substitute dr into h by capital R. In place of y, yes, you can replace this. Small r into h by capital R. Substitute. Yeah, here itself I will write. Y is equal to small r into h by capital R. In place of y, substitute here. This one, boys. Okay. In place of dy, yes, yeah, you can substitute this. dy is equal to dr into h by capital R. If you do the integration, yes, then the result is this. Yeah, I have that with me. Yes, yeah, this will be mu naught q r square omega whole divided by 8 pi z cube. But the given solution for you in the given option, right? Yeah, I think I can rub off this part. In the given option, what they have said is, this is n mu naught q r square omega by 4 pi multiplied by z cube. So obviously compare this, n will be equal to 1 by 2. Yes, that is your answer. Okay.